Well, hello everybody. Welcome to the Sheffield Wind Farm. We're glad you made it through the snow and ice this morning. I came over from Chittenden County, and yeah, I had black ice, and then I had slush, and then I had snow, so took a little while. But I'm Josh Bagnato. I work for First Wind. We own and operate this project, and I work on the environmental affairs team, and I was involved in the development of the project, construction compliance, and then help with compliance during operations and managing studies. And this is Brad Drake.
I'm Brad Drake. I'm operations manager here at the site. I had the pleasure of actually working on the contractor side during construction. So I was an environmental compliance manager and field engineer, quality control during construction. So while now on the operating side, I do have a nice background and a lot of insight to the site during construction.
Sure. I'm John LaMontagne. I'm based out of our Boston office. I work on communications.
His car is the one that's in the ditch.
That's right. My car is the one in the dish, so that's how I'll be known.
So we were going to just give a quick 15 or 20 minute presentation. I think it'll answer a lot of questions folks might have about the wind farm, and then the plans to go in the snowcat, and then go for, we can head up to one of the turbine strings, and then come back, and we can come back here and have more questions. We can do questions in the back of the snowcat. The way it's going to work is Brad's going to drive the snowcat, and I'm going to be in the back with you folks. So I can answer probably most of them, but not all of the ones that relate to operations. Brad will be the better person to answer those. So,
and can I just, let me just interject, as much as possible, if we can have the substantive questions be here so that the videographer gets them. Are you going to take that up? And you're going to be in the back of the cat too? Okay, well then I guess I don't have to worry about that. And
and you need to leave here at 12. So we should leave. We should walk out of here by 11 to have at the latest.
Yes.
To have time to drive up. The cat doesn't go very fast, and we figure you all want to get up close to the turbine, so we should definitely make sure we save time for that.
Yeah.
The turbines are operating now. It's windy enough to operate, but they might be on a.
Let me just see exactly what we're.
There might be some icing going on, so I don't know. Brad will figure out if they've been curtailed at all to deal with the icing. So he'll check out the computer. So I'll just quickly go through the project and who we are, and stop me at any point, obviously, to ask questions. Do you guys want to introduce yourselves, or does everybody know who everybody else is?
We introduced ourselves, right?
Okay.
Except we don't know. Are you Amy?
Yes, I am.
Hi, Amy.
Are you Jan?
I'm Jan.
Hi, nice to meet you.
Nice to meet you. Amy's with the Caledonian Record.
Cut one of the lights.
Hi, nice to meet you.
What do you want to turn the lights off?
Just one of them, maybe?
Sure.
And for me, quickly, can we just quickly run through names
Okay.
and positions so I know?
I'm Anne Margolis, state of Vermont.
Joe Arborio, Island Pond.
This is Tom Baudet, Zoning Commission. And I'm Jan Eastman on the Commission.
Scott Johnstone on the commission.
Bud Thompson, just a public member from Lindenville.
Yeah, lucky enough
Retired
to draw the
for
right
many
figure.
years.
Yeah.
Eric Fertile, Moonlight Video.
Linda McGinnis, Director of the Commission.
Lisa McCarran, Commission Member.
Gay Simington, Commissioner Member.
Pam Arborio, second Arborio, lucky enough to draw the lottery.
Thank you very much.
Did you guys buy some lottery tickets?
No,
Well,
I did.
They smushed together something.
So welcome all. My plan and Brad's plan is just to tell you a little bit about the site, answer whatever questions you have, give you the facts, and tell you a little bit about our company, because I think we operate a wind project in Vermont, but we also operate 16 others in other states. And so we're called First Wind. We're based in Boston. We've been around since about 2002. I've been with the company since 2007. So I've worked on a lot of these projects. Quickly run through this. Founded in 2002, about 175 employees. We have small projects, 15 megawatt projects, to large projects, 205 megawatt projects. That's a project in Utah. What's different about us, slightly different, is we develop the projects, then we build the projects, and then we own and operate the projects. So we're with these projects for 20, 25 year, maybe even longer time periods. Some wind developers, they develop them, then they sell them. Some wind developers buy development rights, and then they build them. So we sort of do all three of them. We're getting to be a larger company. We've raised a lot of money to support building these wind projects. Just a snapshot of what our wind farms look like. They look very different. Our first one was on the island of Maui. Our second one was way up in northern Maine on Mars Hill, which is the name of the town. We then built one on the old Bethlehem steel mill outside of Buffalo. Then we built one in the cornfields in Cohocton, New York, which is south of Rochester. Then built one on a wooded ridge in sort of way northeastern Maine, but further south than Mars Hill. Then we built one in the High Plains Desert in southwest Milford. The power here gets sold to Los Angeles. Another one on a ridge close to the Stetson project in Rollins, Maine. Then Sheffield was our next one after that. This Sheffield went online October 2011. You can see these megawatt, this is the size of them, 51 megawatts, 42, 35, 125, 83. Sheffield is 40 megawatts, so it's sort of a smaller project. For our company, it's actually a smaller project for the wind industry. 16 2.5 megawatt machines. Then we built one in Kahuku on the island of Oahu. Same type of machine, just less of them, 12 of these. We just finished a project in October in Bull Hill, Maine, which is down east Maine, sort of on the way to Bar Harbor. This is at about 450 feet in elevation. Then another one on Oahu called Kauailoa, the largest wind project in Hawaii. And just commissioned one in December in Palouse. This is in southeast Washington State. So I've been involved in sort of almost all of these projects except really these two were before my time. So you can see we build in deserts, we build in tropical areas, we build in brownfield sites, and on ridges. So anchored in New England, you can see most of our development is in Maine, and that's probably where most of our future development in the short term is going to be. One project in Vermont, we're active in Massachusetts, a little bit in New Hampshire, so that's really where we've been and where we're going. Sheffield, I talked about this, 40 megawatts. Took about 5 or 6 years to permit this project. I was involved in about the last 4 years of that. Started construction on September 14th. Took about 13 months to build it. All the power is sold in Vermont. We have 3 contracts, Washington Electric, Vermont Electric, and Burlington Electric. All the output goes to them, and that was a condition of the permit as well as something that worked for us. Generates enough power for approximately 15,000 houses annually, and it costs about $90 million to build and probably another $10 million to develop. So a huge amount of money to build a project of this size. This map is probably illegible from where you're sitting, but this is the final design of the project. So all the resources have been mapped. The green are wetlands, the squiggly lines are streams. The red dots are bear-scarred birch trees. We actually had a bear biologist find every birch tree that had a bear scar on it. And we tried to build the project to avoid those beach habitats. This is the existing Velco transmission line, 115 kV line. So some people think we built that for this project. We did not build that. That was always here. One of the reasons this is a good site is because that line basically cuts across the bottom of it. These are the roads that we'll drive on, some of these today, that connect to the 16 turbines. This is Duck Pond Road. You came up here. Interstate 91 is right here, about a half a mile from where we are right now. You're sitting in our operations and maintenance building, which is there. The substation is right next to it. You probably saw it on the way up. All the power from the turbines, Brad, we'll get a little bit into this, is collected by what we call collection lines. 34.5 collection lines are buried under the ground. They all come here, and they come to the surface at the substation. The power is then stepped up to 115 kilovolts, and that's what goes out on the transmission line into the ISO New England grid.
So what is the size of the underground transmission?
34.5.
34.5, and so it's, how many of those do you have?
16. How many? Well, 16 turbines.
So yeah, no, 16 turbines, but just one 34.
Well, there's two. There's 2 collectors.
Okay.
What we call our 2 collector circuits or 2 runs.
All right.
Half the part 8, the other half 8.
But they
they
both come
in
together.
They're in the same trench
Yep.
for a majority of the.
Okay, it's all underground.
And there's also communications fiber in that trench, too, so that we can watch what all these turbines are doing all the time.
In underground, of course, negates the additional clearing of trees and the additional development. Picks up a lot.
And there's a fair amount of rock under the ground here. Okay, so now that's really the overview. Any kind of...
What's in the picture?
What's that?
What's in the picture?
I'll show you in a
All
second.
right.
The back.
Did you have by 2 conservation areas? Or are there 2 conservation areas?
There's one conserved area. So there's 3 landowners here. There's 2 logging companies, Meadows End, Timber Limited, MTL. There's one called Red Dam, which is another logging company, and then there's an individual landowner who has one turbine. So we lease land from them, and they get payments. And Meadows End went into an agreement with us where they're conserving about 2,700 acres, roughly kind of an area like this, because their land extends not only there, but all the way there. So it extends all the way around here, and that's going to be conserved for the life of the project. The other thing that did is, Meadows End logging companies in Vermont and in the Northeast are really struggling. So by them being able to get lease payments from this project really allows them to keep this land the way it is now. Otherwise, they may have been looking at other revenue opportunities for this land. So that is the final design. Any kind of big questions, background questions? So what I'll go now into is that's sort of the past, and now we're going to go into the present, which is what's been happening during operations. One of the things I do is I'm responsible for making sure that all the things that the state asked us to do in the Certificate of Public Good, we're doing. And what we're supposed to be doing is studying the impact. So we're doing really 3 main studies. The first one is we're doing a bat curtailment study, and that's an injured bat that we found on site that we actually rehabilitated and released. Bat curtailment study, for those of you who don't know what that means, bats in the summer migrate. There's sort of 2 types of bats in Vermont. There's hibernating bats, and then there's migratory bats. The hibernating bats are the ones that stay around here 12 months a year. They're the ones that are susceptible to white nose syndrome. The migratory bats are the ones that migrate through here just like birds. And we found that wind turbines, or the industry's found that wind turbines are, these migratory bats are pretty susceptible to colliding with wind turbines. One of the ways you can reduce the collisions is you can basically not allow the turbines to start during this migratory season during low wind conditions. So these turbines usually want to turn on at about 3.5 meters per second. During certain months, we don't let them turn on until 6 meters per second because it's those warm nights with low winds that the bats are migrating through. So the industry has studied this for several years, not in the Northeast, but in the Mid-Atlantic, where really bat fatalities have been even more of a problem. And they found that by curtailing the turbines to some amount of time during the year and some amount of wind speed, you can reduce bat mortality somewhere between 40 and 90%, depending on what study you look at. So we agreed to do this many years ago, voluntarily agreed to curtail our turbines, which of course leads to revenue loss. And then we agreed to study it. So we've worked closely with Vermont A&R, Scott Darling. We got a grant from U.S. Fish and Wildlife Service for this. Oops, sorry, I was supposed to turn this off. Sorry. And we did the first year of study. So this was done by master's students out of Texas Tech and 4 other technicians who were on site for about 6 months. They lived in a cabin right over there. So this is when we curtail the turbines, June 1st to September 30. This is, we don't allow the turbines to turn on until this wind speed. It's got to be warmer than 49 degrees because bats don't fly around when it's really cold. We search every single turbine every day during that time period to look for dead bats under them. For the study period, we did 8 that were on and 8 that we curtailed to have sort of a control to see if mortality was different between the turbines that were curtailed and the turbines that were not. And what we found is that we found 83 dead bats during the study. BCI has not released the report yet, but it's any day they're going to release it. It'll go to the state. It'll go to Scott Darling. It'll probably be published in some journal or something. And we're going to do it again next year. So what we found is that migratory bats have died as a result of this project. There are no protected bats, state or federal protected bats that were killed. The state and federal protected bats that are being put on the endangered species list are the ones that are susceptible to white nose. So the project didn't kill any of those. So basically it's these 3 migratory species that the project is killing. And we did find preliminarily that curtailing turbines is reducing fatality of these migratory birds. So of these 83 bats, many more of them were found on non-curtailed turbines than curtailed turbines. So curtailment will be a part of this project for the life of it. And the information from this project will be used by the industry for other projects. I think I went through all this. The revenue losses were quite a bit higher than we had projected. So this is, of course, one of, the benefits is less bats. The negative is that less revenue, less clean energy going into the grid. We'll conduct another study here next year, and then we'll probably conduct a 2-year study in coastal Maine to see how it works in that kind of habitat. So that's bat curtailment. I would say that bird impacts, I don't have the numbers right here, but I think they found, do you recall offhand?
It was actually less than the bats, which is not typical, but, and I can't remember the number, I don't even.
Yeah, I mean, quite a few less birds were found. We study impacts from all our wind projects. It's the standard condition, no matter what state you're in. We're finding that birds are not really an issue. I mean, these turbines, we are finding dead birds at the bottom, of them, but at much, much, much lower numbers than bats. Not killing eagles, not killing raptors generally. So birds are colliding with them, but we feel like it's really not a significant impact to any of those populations. The second thing is we are doing a sound study. We've completed our sound study. So the Sheffield sound limit is 30 dBA inside a structure. This is the only state I've ever come across that has a sound limit inside a house. It's very challenging to measure sound inside a house because there's other noises in a house. So what our CPG required is that we do 4 seasons of monitoring at 4 locations, north, south, east, west, around the project. The sound consultant puts sound monitors on trees or telephone poles and just lets them run for 2 weeks straight. And then comes back after 2 weeks, takes the monitors off, and then basically comes up with average sound levels across the 2-week time period. They also take monitors and they put them further away from the project, but in a similar location, so that we can understand the background at that location where you have your primary monitor, and then you can figure out what the background would be further away. So that's a way to get the background out of the primary monitor. So you're just trying to understand sound at the primary monitors just from the wind farm. What further complicates this is you now need to figure out what is the difference between the sound outside of a structure versus inside of a structure. So we went to a lot of people's houses around Sheffield and asked if we could put microphones in their house. 2 people said yes. One was a dorm, King George School, and another was a gentleman over in Barton. So we measured the difference, sort of the attenuation factor of those structures. And then that gave us a number which we applied. So if you had whatever, if 35 was your number outside, you would subtract this attenuation factor, which was about 30, to get your compliance number inside, which was 5 in that example. So we did 4 rounds of monitoring. The project has been deemed compliant by the consultant in all 4 rounds. All those results have been submitted to the state. We've not heard back from the state on anything related to those, but we're assuming that they've been accepted and everything is copacetic. We've gotten 2 complaints from this project. From the public, we have a protocol to respond to complaints, and basically that protocol is we can take the numbers from these monitors and we can extrapolate to the complainant's location, and if the number is within 3 dBA of this 30 dBA limit, we're required to go monitor. So at the 2 locations where we got complaints, the consultant did that extrapolation and found that it would be well below 27, which would be the number, and therefore no monitoring was required. So those are the 2 complaints. We received one about 3 months after we started. And we received another one from a family that's been in the newspapers a lot. I think you folks have heard from them. They've complained many times. We've tried to talk to them. We've tried to kind of understand their concerns and see what we could do, and we've not been able to sort of reach any agreement with them. So that's the sound study and how we respond to complaints. This is just to give you a sense of where we're monitoring. So obviously here's the turbines. You folks are right about here. You're about 2,300 feet from a turbine here. The closest houses, this is a mile limit here. So you can see the houses are kind of out at that mile limit. We put the monitors at houses as close as we could find to the turbine. So here, 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 and here in the 4 locations. And then the background monitors were put further away. So that's how we did our sound monitoring, and again, those studies have all been submitted.
And so there's no houses closer than where we're sitting?
No.
Sounds like.
Not even close.
Great, thanks.
The closest house is how close?
It's that SW4, that orange one looks like
Right
the
there.
closest.
This is the dorm, so this was...
The other one, though, up on Dutch.
Yeah, and this is about 4,400 feet. I think, don't quote me on that,
You
please,
said we're like, what,
videographer,
23?
but something on the order of that.
Was
What's
it
that?
like 23 you said? 22, 23?
I think we're about that, yeah. We should measure it on Google Earth. I measured it
That's
before.
accurate, yeah.
But when
That's
we come out of here, you can listen. There's a cabin here. We had 5 folks stay in that cabin for 5 months this year and really didn't have any issues with the sound. So, yeah, that's the sound story. Here's the results. So, sound studies are unfortunately complicated. What these mean, so these are the 4 monitoring locations, 1, 2, 3, 4. The peak would be the highest sort of 10-minute sound that those microphones picked up over 2 weeks. So that's the highest sound, and this is after you've subtracted out the attenuation factor of the structure. So they were higher than this outside, but then you subtract out. So this is sort of a more typical maximum, so that's sort of the peak that occurs, a handful of times. Again, really kind of high levels, and then this is the average. So you can see 0, 0, 0, 7, 5, 0. These are 2 different standards. LEQ is really an average. L90 is really the 10% of the quietest time. So you can also measure at L10, which would be the opposite of L90. So our sound consultant, who's done sound monitoring, all throughout the world, all throughout America, he couldn't really pick up the sound at many of these locations. He couldn't really decipher the turbine sound from other sounds. So he is, there's statements in the report that he feels that this project is fully in compliance. And then these are the 2 numbers from the complaints that we got. Remember I said we do this extrapolation, we come up with what would be the number at that location, and those are the 2 numbers.
Isn't there also a different kind of sound, not an audible sound, but a low-level sound that is not readily apparent that can travel out?
The literature that I've read and the advice that I've gotten from experts who know this stuff a lot better than me is that's not a product of wind turbines. That's
It's yet to be proven that that exists.
Yeah.
Okay, so those studies that are being done are yet to...
No sound consultant has sort of picked up. I think you're talking about low frequency sound or
Exactly. I know there's a study
infrasound.
going on in
Infrasound.
Canada for infrasound,
Yeah.
yeah.
So this sound is not anywhere near like the jets over in Burlington they're complaining about, right?
Well, listen for yourself and see what you hear. What's the
We're over
production
20
right
megawatts
now?
right now, so we're over 50% capacity.
The jet went over when we were at the South Burlington Solar.
So
Oh,
when they
okay.
get the F-35s over there, that should be interesting.
So Brad's saying, just so you know, it's about 50% capacity. And is that a function of the wind not being strong enough, or?
Some icing
Yeah.
and the wind. It's a combination. It's not the windiest day, and there is some ice buildup, so that slows the turbines down. They have to work harder. But hear for yourself, when we get out, there's not a large difference between wind speeds or operations of about 50% capacity and 100%
Right.
capacity. They don't ramp up that much more or become that much louder. So you'll hear a very representative example when we walk outside, being closer than any other resident to the closest windmill, and you guys can see.
Yes, I think what Brad's saying is, what happens with the sound levels is as the energy of the turbine increases, it gets to a point where it just flatlines. So I don't know where it starts flatlining, but basically, half capacity could represent almost maximum sound. Probably not maximum sound, but you're getting close
But not
to
far
it.
off.
Is that the sound from the propeller part of it and the wind resistance, or is it the turbine itself?
It is a function of the blade cutting through air.
Uh-huh.
It is not a mechanical sound.
So you don't, the turbine itself is
No.
not creating
The only
sound.
mechanical sound you'll hear, and if we can hear it with the winds when we get up there, is the humming of the transformer at the base.
Uh-huh.
And as well, when the nacelle, and we'll get to this in a second, will turn into the wind, you will have a mechanical sound from that, but it's you can't usually hear that over the wind standing 50 feet from the turbine.
And what again was the attenuation factor you considered for a building? If these are inside the building.
So 30, I think he came up with 38 and 35 were the numbers. And then the 2 locations that people wouldn't let us in their house, he just dropped that to 30 to try to be more conservative.
So meaning that peak of 20 would have been what outside?
So that peak of...
Would it be 58 or would it be, what
So
should you
20,
add?
so
to
you
20?
would have added, I think you would have added here 30, so it would have been 50.
50.
But again, that's a short, instantaneous 50, and yeah.
Yeah.
So that's
And
what
you'll
that-
have to look online. I can't remember the comparisons, but I think normal talking volume is 60 or 40, something like that. I can't remember.
Excuse me, what was that you said?
I think,
No,
I think the normal speaking level is 60
Okay,
dBA or 40. I can't remember the number, but it's around there.
thank
And I'm sorry, I wanted to go back to, you were saying today, can you give us an estimate of the capacity that it's running at?
Yeah, I'll look
50%,
again.
50, I didn't know.
I'll look again right before we walk
Okay.
out, but it was at over 20 megawatts a second ago when I looked, which is over 50%.
Okay.
And what's its load factor, winter peak, summer peak? Do you have any data on that? So basically, how's it running either on a hot summer day?
Yes.
Or on a very cold?
So during winter months, our capacity factor is way up compared to the dead of summer. Winds in the northeast, as a function of the storms and the cells and the winter storms and the winter cells that we get, are definitely more significant for production than in the dead of summer.
Yeah, I'm just wondering if
Absolutely.
you're doing any
Right now.
correlation between peak day,
Right.
Vermont peak day, and production, both winter peak, summer peak?
So is a wind project correlate with peak energy usage
Yeah, that's
days?
the question. What's your load factor on a peak day?
I don't know. We haven't studied that.
If you don't know, I mean, I'm just
Yeah,
really
no.
curious.
No, I'm not sure.
Okay.
This is the last little study I'll talk about. This is not a study we did. This is a study that Vermont Agency of Natural Resources did. So we were in court in Vermont for almost 3 years with an appeal against a construction stormwater permit. And there was a lot of experts were brought in on the appellant side saying that it would be no way you could keep the water quality of the streams clean and build a project like this. And it went back and forth in 14 days of court. The appeal was overturned by the Vermont Environmental Court. It was then appealed to the Vermont Supreme Court. And then once we started constructing the project, the appeal was dropped. There was also 2 stay attempts to stop the project during construction, basically accusing us of violations of water quality. The state of Vermont has been monitoring water quality at streams really in all directions of the project since prior to 2006. They've got a very apparently progressive stream water quality monitoring program. And they do it all over the state. And they've got data from streams all over the state. And what they do is they basically do macroinvertebrate kick studies. They just take nets, they kick the rocks, and they see how many bugs are living in it, what's the diversity of them, what's the density per square foot. And I don't understand most of these metrics, but I will tell you that green dots means the stream's healthy, and red dots and going into blue dots fails to meet A&R bio criteria, meets A&R bio criteria. So they did in 2006. Again, this is pre-construction here. Pre-construction, pre-construction. This is during construction, and this is post-construction. I just got the results yesterday. They just finished 2012, and I think all the dots have turned green. So you can see what this shows us is there's no impact to water quality based on the research the Vermont biologists are doing in these streams. So, in my mind, we've proven that you can build a project like this and not impact water quality. And I'm glad the state did the water study. We didn't even know they were doing it until they asked us one time, could they come on the site and go look at the streams. I'll turn it over to Brad now to get to the more interesting part, which is how you operate one of these projects.
Yes. So for operations, myself, a wind support specialist, Catherine Morell, and I lead up the in-house operations. I'm not going to go into my background. I've been in renewables and building wind and solar for quite a few years. Catherine has a lot of experience in conservation and power utility research. She lived in Antarctica for a while and then came back to Warren, Vermont. Our site turbine technicians, we have 4 full-time employees solely responsible for the maintenance and the repair and response to any issues that would occur. They're the unsung heroes of the farm. They really keep the turbines turning. They're a really dedicated crew, and we really couldn't do it without them. These turbines do require maintenance like a car or any other type of mechanical machine. Oil changes, fuses, fan belts. They need some of the occasional maintenance to keep things going. So we've talked about some of this, and I'm going to move rather quickly so we have enough time to get on site and you guys aren't late for your next appointment on the agenda. We have a total capacity of 40 megawatts. That's 16 turbines of 2.5 megawatts each. And I'll talk a little bit more at the turbine about this, but they produce 690 volts AC, which is converted into that 34.5 at the base of the tower in a transformer down there. That's stepped up to get it down to the substation. So you have to have a higher factor for transmission of power. So that comes down to the substation. It goes through our large T1 transformer, which then steps it up again to 115,000 volts. That's transmission grade, which then leaves on the Velco line and into the grid. You're in the ops building here, the substation you can see on your left as you come up the hill. Those are really the only structures built on site, besides for the turbines and the roads themselves. That was not existing.
So your interconnection level is 34.5. You don't own any 115 level.
No, no, the transmission connection is 115. It goes through our transformer to 115.
And then you
then
own...
it hits the Velco side.
So you actually own that piece between your transformer and the Velco substation?
No, we don't own any.
Any 115?
We actually built, this substation has two sides, so we built the whole thing, and half of it's Velco's. We basically gave it to Velco.
Okay,
And
got
that's
it.
theirs, and that's on
And
the
at the
115
115 side, at the switch, it goes to them. Monitoring the Sheffield wind farm, a lot of people aren't aware, so there's there's actually three, but there's two first wind DACs, or data acquisition and control centers, with 24/7, 365 monitoring of each and every wind farm, but specifically as well this one and each and every turbine. There's also actually a third monitoring control center in Cedar Rapids, Iowa. So these guys, they have real-time control. They notify us in real time of any issues, concerns, a fuse goes. We have icing. We need to know what we need to do. We have different operating procedures for icing and stuff like that to keep down the wear and tear of the machines and things of that nature. Curtailments that come in from the ISO New England regulatory curtailments to the site, or curtailments from the other utilities that we supply to. Those are all sent in real time, and the monitoring is real time.
Would you, if you got a request to curtail from one of the BEC, one of the folks with the
I say Velco.
Because I was just really curious, you wouldn't take a curtailment order from one of those distribution companies?
From a utility?
From a utility, we would. I mean, we have to, in most of the curtailment, I've never seen a curtailment from BED or from WEC. Velco will have line upgrades.
Well, Velco's a different issue, but yeah, okay.
Yeah,
just
but
really...
no. And typically 90% of curtailment comes from ISO New England. Just some of the technical aspects of the turbine. You have your nacelle, is the very top housing, with your hub, rotor, and blades. These towers to the top of that nacelle are 262 feet at this site. The rotor diameter is 305 feet. Each blade's around 150 feet. To the tip of the blade, from the base, you have a 414-foot tall dimension. I'm going to keep going. That's the internal cutaway of the nacelle. And I won't spend too much time on this, but within the hub, as the blades turn, they go through a giant bull gear, or gearbox, which is then transfers that power to 4 main generators up in that nacelle. Those generators are what step up the power to and convert the power to AC, to 690 volts. And then there's transmission lines, which you'll see in an upcoming slide, down the tower to that transformer, again stepping it up to 34.5. This is your bull gear, and this is the gearbox. These are those transmission lines I was just referring to at the tower. And that is how we get up there, just a ladder.
Now, the Clipper factory doesn't exist anymore, does it?
No, well, yes. There is Clipper still in Cedar Rapids, and it still does maintenance and repairs and gearbox.
They're just not producing any blades?
They don't produce blades and never have. Okay. The blades are from a different vendor. Okay. Yeah. But Clipper's the gearboxes and the internal workings. The cans, we call them, and the blades and the fiberglass are fabricated by different companies. There's some of the technicians like I said, they're really the guys that come in at 11 p.m. on a Saturday if we need a fuse replaced real quick to keep a turbine up. Any other questions? All right. I'm going to go fire that Snowcat up, let it warm up for about 5 minutes. Everybody hit the bathroom or coffee if they want, and then we'll head
I would say that if you want to go out and listen before the Snowcat turns on, now's your chance.
Great, good idea. That's what I'd like to do.
The little brown bat and the northern long-eared bat, I believe, is another one. So there was
two bats that come and live in the east and whatnot.
probably a little brown bat.
And then they go away.
Probably little brown.
Yeah, which is, make sure you invite them every year. There's not a lot of roosting spots left.
I don't do anything. It's an outbuilding, and they only way I know that they're there is to poop.
Yeah, that's great. Yeah.
And then every once in a while you'll see them.
Is that known as scat?
Yes.
I know my
I'm
scat.
impressed. I'm impressed.
Thank you very much.
Synonyms for animal poop are very impressive.
I had it in one class one time.
Someone's not letting him go?
No, hold on.
Do you want me to put that in the paper? Are you proud of that?
No. Yeah. No, that's all right.
Great.
No, I'm serious, Josh. When I see the figure 83 bats, it's infinitesimal. It's nothing. In my way of looking at it. Am I wrong?
Yeah. People.
Yeah, I mean, I work on an environmental team, so I don't want to see us killing any bats, but yeah.
83 out of how many?
Well, those migratory bats, the populations are pretty robust, but honestly, there's not nearly as much research on bats as there are on birds. People really want to study birds, people don't really want to study bats. Now that bats are really in trouble, particularly the non-migratory ones, they're getting a lot more attention, as they should, so.
Now, because bats use sonar, would they be able to put a small sound device on there that would deter them?
There is ideas out there, there is technology like that. They've not figured it out to be particularly effective, but it's definitely something the industry keeps looking at. So there were a lot of existing logging roads that we sort of built up and improved, but these are about 16-foot wide roads, so very narrow for a wind farm. They're often a lot wider in other places. And then what you can't see is there's a series of ditches next to the roads, all along these roads, and all those ditches, there's a dirty side of the road, a dirty ditch, and a clean ditch. All the roads are slanted to put the water in the dirty ditch, and then the dirty ditch water goes to basins, stormwater basins, and then the idea is the sediment sort of drops to the bottom of the basin and the clean water returns to the environment. And then the uphill side of the road is the clean ditches, and those flow to, wherever, into the woods or into a stream.
Were you restricted on the width, pardon me?
Yes.
On the width of the road?
Yeah, I mean, every tree we could cut was permitted. You couldn't go beyond, your limits. And we had to build these basins and these ditches as we built the roads. So you couldn't just kind of forge roads way out. You had to build all the stormwater infrastructure as you went along. So it was a very slow way to construct a wind project. And then we had to go after...
Did you drink a lot during this project?
Water. Yeah, well, there was a lot, you're
He's trying to get you some good quotes. See, he's working
You should have done background checks for the lottery. I didn't get picked and he did. What's up with that? I behaved perfectly. Nice to see you, bud.
Good to see you, Amy.
Thank you. I appreciate that. Thank you.
You're the best.
I should know the answer to that question.
I'm
I
just told.
think
I've been
there's
doing it a long
about
time.
9, and about 3 or so already existed, and we built about 6.
Oh, yeah. I'm better than him.
And these
I
are
know.
gravel roads.
I know
Most
that.
of the disturbed area, with the exception of the gravel roads and some gravel, we leave crane pads. So those are gravel squares by the turbines. You're not going to see those, obviously. Everything else is revegetated. So, over time, areas like this where you see a little bit of clearing next to the road, that should all kind of grow back, and you just have this narrow road.
When you do decommissioning...
What's that?
When you do decommissioning, what is your responsibility?
We have to post a letter of credit with the state, which is basically, it's like a promise for cash.
No, not as far as that goes. When you decommission, as far as leaving this land or bringing it back to its environmental...
Yeah, so you gotta take all the turbines out. You've got to take obviously the transformers out, the collection out. You've got to take the foundations. I think it's 12 inches below the ground. I don't know the exact details of the decommission, but you've got to basically dig out a certain amount, and they just basically revegetate everything.
How much is below ground?
I think it's 12 inches, but it's in a decommissioning.
How about the road report? What do you have?
Roads, I think the roads can stay. I have to look at the decommissioning report. It's all detailed in there, what we have to do. I work on like 16 different projects, so every project has a decommissioning commitment, and they're slightly different, so the exact specifics are sometimes...
Does this company have to have so much money always in escrow account?
Yes.
So
It's called a letter of credit is what we call it. Just basically we've got to pay every year to have that letter of credit sit with the state of Vermont. So in the fact that if anything happened to the project, anything happened to our company, they can cash that and use that money to decommission it.
Can you talk a little bit about the process of your permitting, the various types of public engagement that you all did, and what's different about this project as a result of that interaction?
So a lot of the public process really occurred prior to me starting. So I started in May 2007 with the company, and we got the permit in, I think, October 2007. So most of that I wasn't physically there at that, but obviously I've heard stories. I mean, there was the public hearings, the Public Service Board sponsored hearings, which went on for days. There was a lot of experts hired on both sides, and so there was a lot of input, and the project was really shaped by that input. There was input from the public, there was input from experts hired by the public, there was input from the state, there was input from the federal government, and that led to, we had 23 turbines at once. At one point, we went to 16 because the town of Sutton didn't want to host the project, so we pulled all the turbines out of that. We had roads going through bear-scarred beach habitat, bear habitat. The state didn't want us doing that, pulled the roads out of there. Even though those roads would have been flatter, we then moved them out of there, so now they're not as flat, so you had to do more grading. The conservation land I spoke about earlier, that was a product of public input. The curtailment study that we're doing and the voluntary curtailment, that was through the state biologists really feeling like this is going to be an impact from this project, impacts the bats, so let's study it. Or we don't know if it's going to be, so let's study it. We had wetland impacts of 0.6 acres at one point. We brought them down to 0.08 acre. That was all based on input from the public. So the public shaped this project. If we could have drawn the project the way we wanted, it would not look anything like this. One thing that's unique, I think, about our...
Do you think that's for the better or the worse?
Absolutely. Yeah. And one thing that our company has, which I think is a little unique, is we have an environmental affairs team. So I'm part of it. We have biologists on our team who are constantly trying to find ways to sort of reduce the impacts of these projects. So you just passed the first turbine behind you. If you look out your back window, you can see the base of it. Here's a huge stormwater basin right there.
We were right under it, too. He wasn't kidding. You can see it right up through there.
The next turbine's going to be on the right-hand side. This is turbine 2. We had a ribbon cutting, 14 months ago. You guys want me to close this, or is it?
It's filming through it?
No.
I can pause.
So this is where we had the ribbon cutting over here.
The first one?
Maybe you should sit in front and wait back.
Oh, that's a good idea. But then I wouldn't be able to hear the... I guess maybe we'll do the questions now. I think the video is really going to capture the bumpy ride.
All right, here's our next turbine, turbine 2. It is always colder and windier here than anywhere else. Sheffield Heights.
What is the elevation?
The highest turbine is just at 2,500 feet. Right now we're at about 1,800 feet. That O&M building though is pretty high. When you get off the highway in Sheffield, all you're doing is going uphill for about 7 miles. So we're at a height of land where we started the project.
So it's one of your basins here?
That's a basin. Yeah, that's the largest basin on the project. So the deal with these basins is they do treat the water, but you also have to disturb a lot more land to put them in. These basins are what you'd find like on a Walmart parking lot. I think they're a little bit over designed for a project like this. But Vermont, the stormwater regs really don't differentiate, or they didn't at the time we built this project, they don't differentiate between a gravel road in the woods that maybe one truck drives on a day versus a paved parking lot outside of a Walmart in Williston where you have 7,000 leaking cars parking every day. It's the same exact standard.
Yeah.
How far are we from that turbine? That we just went by on that stuff.
Everybody, hold on.
Now, we got close to that with hurricanes, with Sandy. And Irene, we were building this project during it. So, and it held up really well.
Because it was different directions.
I mean, this stormwater infrastructure we built it's really hard to see it, but it's a major amount of work to get this in and get all these ditches and stuff. There's 26 of these basins around the property site.
I'd be curious as to if you were to say what you think is sufficient, because at least from what it sounds like from your perspective, the stormwater was a little overkill. Do you think that there's a way to have different regulations for stormwater for this type of thing? I mean, if you just
other developments, and the federal government came down incredibly hard on Vermont. It was going to take away the program for a while. We weren't doing any construction virtually of anything in Vermont because nobody could get a stormwater permit. So the thing about stormwater, that one's hard for you guys now, but it is. But it's
all about Lake Champlain, isn't it? Really?
Yeah, it's all about, and we were going to say no to a lot of stuff.
No, I think
for us to come up with a program was.
There's definitely some basins that are definitely needed and really enhance the project. At the bottom of the stone sections of roads or something. Places where by the time it rains and the water goes down those stone line ditches, it's infiltrated into the ground and never even makes it to the basins. So, again, they treat a gravel road like pavement. So water just doesn't, it's not going to sheet flow off this gravel.
Except May of last year, in each of Barnet, where roads that have been there for 300 years were gone.
Right.
It's kind of strange.
It's kind of strange.
Yeah, we got close to that with hurricane.
Then they have to keep the original.
No, the first one is Searsburg.
Yeah.
Yep. I guess it's the fourth sort of modern day, maybe you could say. I mean, those turbines are, I think, 0.5 megawatt turbines, and these are 2.5, so it's really a bit of a difference, technology.
Some people have talked about the possibility of using helicopters to do the construction. I don't know if your company has done that anywhere. And
we've used helicopters to install transmission lines, which is actually pretty typical out west. And that's a great way to not disturb the ground between the transmission lines. Some of those, desert type grounds are really, those plants take 10 years to regrow. But out east, I don't.
You don't know of anybody that's done that?
Oh, do they?
Oh yeah, the Hydro-Quebec line. Are the pieces light enough for helicopters?
I don't know that anybody's built a wind farm with a helicopter.
Even in the West? I thought I had
not that I'm aware of, but maybe they have. I mean, these are pretty heavy pieces of equipment, so you really need a major helicopter.
We have two of these, and the other one is a totally different dynamic driving, much easier to drive. This one is very, very sensitive. Like to turn, I just barely move this steering wheel. It's a beautiful shot right here. On clear days, you can see the whole park. It's really just gorgeous.
what I can see is 4 turbines directly in front of us, mostly in the clouds there in the snow. How to use the plow?
Yeah, well, we made the decision to not plow the site in winter anymore because what you'd see over time is degradation of the stormwater system here. Because the stormwater system is so complex and robust and important, we wanted to do anything we could to maintain its integrity and not have to do reconstruction every year on it or the roads near as much. You're always going to have some slight cosmetic construction in the spring and summer every year just from wear and tear. But with plowing, you're going to add a lot of snow and ice into your stormwater channels, and they're not going to naturally thaw down during the spring thaw. You're going to have some more ice blockage. Your stormwater system is not going to function at 100%, and that's paramount to us that it does. So we looked at that and we decided if we use snowcats or track vehicles all winter and don't plow, we're going to see a much more stable stormwater system over the life of the farm.